I am Shani Sharma, Assistant Professor, IMSA Ghaziabad, University Coast Campuses. Let's start the topic Enzyme Kinetics and its graph. First, I will tell about enzyme kinetics. Enzyme kinetics is the study of enzyme catalyzed reaction to determine the rate of reaction. Either the rate of reaction may be a slow or it may be a fast, and it determines how it changes in response to change in experimental parameter. Substrate concentration affect the enzyme catalyzed reaction, as we know that the substrate concentration changes during the concentration of the reaction as substrate is converted to product. At relatively low concentration of substrate, initial velocity increases almost nearly with increase in substrate concentration. At higher substrate concentration, V naught increases by smaller amount in response to increased substrate concentration. Finally, a point reached beyond which increase in V naught is vanished or stopped as substrate concentration increases. As we all know that substrate concentration is directly proportional to initial velocity. Next, this is the graph of enzyme kinetics, which show that this y-axis show the initial velocity and x-axis show that substrate concentration, where this show that V max, which is a final velocity, and this graph is hyperbola in nature and the hyperbola graph, and it is also show that it is a Michaelis plot. Initial velocity, this is an initial velocity which tell that velocity when little substrate is reacted. Next, there is a three phases of this graph, that is initial velocity and the substrate concentration. The reason for the three phases of the curve can be interpreted. In the first phase, substrate concentration is low. Most of the enzyme molecules are free, so they combine with the substrate molecule, and at this stage enzymatic reactions show first order kinetics. In the second phase, half of the enzyme molecules are bound to the substrate and it show mixed order kinetics. In the third phase, all the enzyme molecules are bound to the substrate, so the velocity remain unchanged, and because free enzymes is not available through the substrate is in excess, at this stage enzymatic reactions show zero order kinetics. And these are the three kinetics which show that first order kinetics, mixed order kinetics and the zero order kinetics. And zero order kinetics show that there is no remain unchanged, velocity remain unchanged. Either we add more substrate but velocity remain unchanged. There is an alternate models for kinetics of enzyme. There are alternate model for kinetics of enzyme and broadly categorized into three basic categories, that is Michaelis mental kinetics, allosteric kinetics and pre-steady state kinetics. But we focus in more on Michaelis mental kinetics. Michaelis mental equation derivation, this shows that when enzyme bind to the substrate, it forms enzyme substrate complex, and then it further react and it forms enzyme plus product. This enzyme is a free enzyme, and the product what we want, that product is this. There, according to Michaelis mental equation, rate of ES formation is always equal to rate of ES breakdown. And they state that according to Michaelis mental equation, rate of ES formation is equal to rate of ES breakdown. Thus, for the steady state consumption, as I have told that according to rate of ES formation and rate of ES breakdown is always equal, this equation shows that rate of ES formation is equal to rate of backward reaction. This equation is the basis for the final Michaelis mental equation, mental following algebraic rearrangement and substitution of Km and Vmax terms. Thus, this is the final equation of Michaelis mental equation according to the enzyme kinetics. V is equal to Vmax, where Vmax is the final velocity substrate concentration upon Km plus substrate concentration, where Km is a Michaelis constant. Michaelis constant is the substrate concentration that produce half the maximum velocity, that is Vmax upon 2 is known as Michaelis constant, which is known as Km. The importance of the meaning of Km, That Michaelis constant has been determined for many of the commonly used enzymes, and the size of Km tell us several things about a particular enzyme. A small Km indicate that the enzyme require only a small amount of substrate to become a saturated. Hence, the maximum velocity is reached at relatively low substrate concentration. At large Km indicate that the need of higher substrate. As we know that substrate increases, initial velocity increases. Initial velocity increases, that means the Michaelis constants indicate that we need higher substrate or low substrate to achieve the maximum reaction velocity. The substrate with the lowest Km upon which the enzyme acts as a catalyst is frequently assumed to be the enzyme natural substrate, though this is not true for all enzymes. Km of 10 to the power minus 7 molarity indicate that the substrate has a greater affinity for the enzyme as we compare with the Km is 10 to the power minus 5 molarity.